All right, ladies and gentlemen, today we are doing 8.3. We're writing and graphing exponential growth functions. The main equation that we're using for this is y equals ab to the x. Since we're using y equals ab to the x, that's like our y equals mx plus b, but for our exponential functions. Okay, so we are going to look at this specific set of numbers, this table, to figure out how to make it into a function y equals ab to the x. Okay, so what we're going to do first, step number one, always use this function. This is the formula that you're sticking everything in. So the first thing I'm going to do is plug in 0 for x to find out what a is. Plug in 0 for x and 8 for y. I'm using those because I'm using it from this chart. Those are the x's, those are the y's. So I'm getting 8 equals a, b to the 0. And the reason I used b is because I used 0 is because anything raised to the 0 power is 1. So I get 8 equals a times 1. So right away, this is step number 2, I know that a is equal to 8. Since I know that a is equal to 8, I'm already partway done with my equation. Okay, so a equals 8. Now, step 3 is finding out what b is. In order to find out what b is, I stick this whole equation again. I've got y equals 8 instead of a, b to the x, and I want to find out what b is. I'm going to stick in 1 and 16, 1 for x, 16 for y, to help me figure out what b is. So I'm getting 16 equals 8 times b to the first. So I have to figure out anything to the first power is itself. So what do I take to the first power that when I multiply it by 8 gives me 16? Well, that's going to be b is going to equal 2. So now I have my final equation, which is going to be y equals 8 times 2 to the x. All right, so we're going to go ahead and move down and look at, graphing these. So we look at graphing exponential functions. So the function I'm going to graph is y equals 2 to the x. And then I'm going to compare it to my next ones. I'm also going to find the domain and range of this function. In order to do this, I'm going to set up a table. I'm going to choose the same numbers all the time unless they give me different ones. I'm going to choose -1, 0, 1, and 2. So I get 2 to the -1. Now, you know we can't have negative exponents, so I'm going to flip it over. And that's going to give me 1 over 2. Now I'm going to take 2 to the 0 power. Anything to the 0 power is always 1. 2 to the first power is just 2, and 2 squared gives me 4. So now I'm going to graph my function right here. I've got -1, and I just go up a half. Don't be confused by fractions. At 0, I'm at 1. At 1, I'm at 2. And at 2, I'm at 4. And you can see that my graph does look very different than a linear equation. It's exponential. Okay, so let's look then at before we move on, let's talk about the domain and the range. The domain in this case is all real numbers. We use that funky R for all real numbers. And we know it's going to look like that because the arrows are going to continue on and on and on forever, and we'll eventually hit all the x's, because x's means domain. For our range, those are the y values. Y is going to come very close, but never hit 0. So y is always greater than 0. So that's our domain and range. So we're going to look at 2 other graphs and be able to compare them. The 2 other graphs that we're looking at is y equals 3 times 2 to the x. And I'm going to do this one in black, and we're going to see how it's different than the second one, which we're going to do, which is y equals -3 times 2 to the x. Okay, Okay, so the first one, again, we're going to make a table. We've got our x's and our y's, and we're going to plug in -1, 0, 1, and 2. When you plug in -1, so we've got 3 times 2 to the -1. Anything to the negative powers we put on the bottom, so we've got 3 times 1 over 2, which when we multiply them together gives us 1½ So I'm going to erase this, and we're going to try it with 2 to the 0 power. 3 times 2 to the 0 power. 2 to the 0 power gives us 1, so we have 3 times 1, which gives us 3. Then we're going to try it using 1. We have 3 times 2 to the first power. 2 to the first power is 2. 3 times 2 is 6. Notice that I'm using order of operations each time. I'm finding the exponent each time. Now I'm going to do it squared. 3 times 2 squared. 2 times 2 is 4. 3 times 4 gives me 12. So now I'm going to plug in it. I've got -1, and I get 1½ I have 0, I get 3. I have 1, you get 6. I have 2, and you have 12, which is off the chart. But see how it goes up. We know our domain and the range is still the same, but it goes up faster. So this is different than y to the 2x because it goes up faster. Now we're going to go ahead and graph the other one in the same graph and see how they're different. We're going to plug in x and y, but we're going to do the same ones again, -1, 0, 1, and 2. So I've got -3 times 2 to the -1. So we put it on the bottom, and we get -3 times 1/2, and we get -1½. Now I do the same thing with 0. I have -3 times 2 to the 0. So I get -3 times 1, because anything to the 0 power is 1. So I'm going to get -3. We should be seeing a pattern, how they're different. Then we plug in 3 to the, we have -3 times 2 to the first power. We get -3 times 2, which gives us -6. And then we're going to plug in 3 squared. We get -3 times 2 squared. So we get -3 times 4, 2 times 2 is 4, and -3 times 4 gives us -12. Now I'm going to graph these in blue. We've got -1, we've got -1½ Make sure you're going down. 0 is -3. 1 is -6. And 2 is -12 is off the charts, but in the other direction. So when we multiply the front number by a negative, the graph goes down instead of up. All right, so now we're going to look at a story problem. So the owner of a 1953 Hudson Hornet convertible sold the car at an auction. The owner bought it in 1984 when its value was $11,000. The value of the car increased at a rate of 6.9% per year. So we're going to, again, use y equals a, b to the x, but just a little bit differently. A is our initial amount of money that we started with, so that's my $11,000. So I know that A equals $11,000. B always stands for my percent. So B equals, now this looks a little funky. We know that 6.9% is 0.069. But if we just did that, we're just calculating the percent. We're not calculating the initial amount of money. So we have to change that to 1.069. So now we're just going to fill it in. We've got y equals, I've got my A, 11,000, times my B, which is 1.069, to the x. Y is how much money it costs, and x is time. So now we're looking at the next part of the problem. The auction took place in 2004. What was the approximate value of the car at the time to the nearest dollar? So since we're looking at time, The initial value of the car was at 1984. So how many years to 2004? It's 20. So you're going to get y equals 11,000 times 1.069 to the 20th, because it's been 20 years. Now we know that car values usually go down, but this is a collectible, and collectibles usually go up depending on how much money people are willing to spend on them. So that's why it's an exponential function. And we get rounded to the nearest dollar. The car was worth at the action $41,778.